In this class, we are going to look at making and breaking bonds. We are looking at making and breaking bonds. Okay, let's take the first one, making bonds. Making bonds. For you to make bond, energy needs to be released to the surrounding. So energy is released to the surrounding during bond making. So energy is released during bond making. So with that, we can say that bond making process is an exothermic reaction. So bond making process is an exothermic reaction. Okay, we now consider the second aspect, which is bond breaking. So that is breaking bonds. So we look at breaking bonds. This aspect, I think, is very simple and clear. For you to break, you will require that you need to put in energy. So breaking of bonds, that is breaking of bonds, breaking bonds takes in energy. Can you see? This is opposite making of bond. It takes in energy. So we can say that breaking of bond is an endothermic process. It's an endothermic process. So taking in of bond, and then to split the energy is an endothermic process. Now let us look at some example of breaking and making of bonds. Okay, we are going to use ammonia for example. This is nitrogen. Three hydrogen. So you discover that I have 3 bonds here. For a chemical reaction to take place, this bond needs to split. Can you see? So the moment you break this bond, then new bonds will be formed. So here is endo, here is endothermic. Then the nitrogen will form a new bond, and then the hydrogen will also form a new bond. You have several of these, several of this. You have several of this. So this now is exothermic. This is exothermic process. Exothermic process. And this is endothermic process. So now for this bond is broken, these 3 bonds are broken, and then new sets of bonds are formed between the atom. So we said that the energy that is required to break the bond here is an endothermic process, and then here we have exothermic process. So this is the reactant. Okay, and this is the product. So we have the reactant to the left and then the product to the right. So the energy at the reactant, endothermic, the energy at the product, exothermic. Okay, we are now going to look at what we call bond energies. Bond energies. So is bond energies. Okay. Now, bond energies, in bond energies are the That is bond energy. I take like this. Bond energy is the energy required. Bond energy is the energy required to make or break bonds. Bond energy is the energy required to make or break bonds. Now, every bond have their equivalent energy. Take for example, hydrogen to hydrogen bond will require about 436 kilojoule a mole. Bond energy will require about 436 kilojoule per mole in order to be broken or made. So the amount of energy you need to break a particular bond is equal to the amount of energy that is released when the bond is made. Okay, the carbon to hydrogen. Let's say carbon to hydrogen. This particular bond will require 435 kilojoule per mole. That is 435 kilojoule per mole to be broken. And I have oxygen to hydrogen. This one, oxygen to hydrogen single bond, will require 464 kilojoule per mole. 464 kilojoule per mole to be broken. Then when you have a carbon to carbon single bond, that is carbon to carbon single bond, this will require about 347 kilojoule per mole. That is 347 kilojoule per mole. Like I told you, this is the value that is required to either make or break this bond. The energy release when the bond is made is equal to the energy you will need to break the bond. Okay, let's look at some double bonds, their value. You don't need to worry about this value. We are going to use it to carry out some calculation in all the time that will be given to you, but I just want you to take note of them. Okay, oxygen to oxygen double bond, where you have oxygen to oxygen double bond. For you to make or break this bond, you need about 498 kilojoule per mole. That is 498 kilojoule per mole. Then carbon to oxygen double bond. Carbon to oxygen double bond will require about 803 kilojoule per mole. That is 803 kilojoule per mole. Then I will just give you one example of triple bond, that is nitrogen to nitrogen triple bond. You will discover that this is the highest of all. We have about 945 kilojoule per mole. That is 945 kilojoule per mole in order to break or make nitrogen to nitrogen triple bond. So, what is the need for all these values? We are going to make use of them to calculate change in heat energy. That is change in heat energy. Okay, now let's look at how to calculate change in heat energy. All right. So we're talking about calculating change in heat, calculating change in heat energy. Okay. All right. Or you can call it heat of reaction. Calculating change in heat energy or heat of reaction. That is heat of reaction. Okay. Right. We are going to represent the heat of reaction with this sign, that is change in heat enthalpy. This will be equal to energy needed to break bond minus energy needed to make bond. That is how we are going to calculate change in heat. The energy we need to break the bond minus the energy we need to make the bond. Okay, we can simply put it in this way. Energy taken in, that is energy taken in minus energy given out. Can you see? Because I told you that the energy taken in, energy is taken in when you break bond. Energy is given out when you make bond. So, how do we do this? We are going to look at a particular example. We are going to look at a particular example. That is example. Have you taken note of the formula? Let's look at a particular example. So we have um, this that is methane plus this 2 of it, 2 of this, and then we have carbon, we have that, and then we have 2 hydrogen, 2 oxygen. Okay, now you need to be careful and look at this. We are going to make use of the value of the bond energies given to you earlier to calculate the energy change of this particular reaction. Okay, now let's look at this one after the other. Carbon to hydrogen, we have 1, 2, 3, 4. So we have let's talk about energy needed to break bond. That is energy needed to break bond. So we have 4 carbon to hydrogen. 4 carbon to hydrogen. Here then 1, 2, 3, 4. And the value is 4 times. So we are going to have 4 times 435. 4 times 435. If you press your calculator, this is going to give you 1740. This will give you 1740 kilojoule per mole. Okay. The next one is oxygen to oxygen double bond. We have 2 of it. So we have 2 oxygen to oxygen double bond. That means 2 times 498. 2 times 498. 198. If you press your calculator, you are going to have 996 kilojoule per mole. That is 996 kilojoule per mole. So we are going to sum the two together for us to get our total energy needed. So we'll look at, okay, this page there. Look at total energy needed. So we have a nice total energy. Okay. This is going to be this plus this. We give us 6. This plus this will give us 13. We carry 1. This plus this will give us 16 plus 1, 27. So this is 2. So we have 2,736 as our total energy needed to break bond. Okay, now let's look at the energy needed to make the bond. And that is going to be at the product side. Okay? If you look at this place carefully, carbon to oxygen is 1. Another carbon to oxygen, that is 2. So we have energy needed to make bond. This, we have 2 carbon to oxygen, and that is 2 times the value of the bond energy. That is going to give us 803. 2 times 803. This will be equal to 1,606. That is 1,606 kilojoule per mole. That is 1,606 kilojoule per mole. The next one is also oxygen to hydrogen. We have 2 of it. That is 2 oxygen to hydrogen. 2 oxygen to hydrogen, and that will be 2 times is water. So we have K, and if you balance the equation, you are going to have 2, and 2 times 2 times 464. That is 464. Okay, why is it so? I have 2 here, and then I have 1 and 2. So that is 2 times 2 times 464. So that is going to give us a total of 1,856. 1,856 kilojoule per mole. Okay, 1,856 kilojoule per mole. So now we'll also calculate our total energy. So we have total energy. In this case, 6 plus 6 will give us 12. This will give us 5 plus 1. That will be 6. This will give us 14. This will give us 2 plus 1. That is 3. I have kilojoule per mole. Okay, you're going to have 3,462 kilojoule per mole. So we have gotten the energy needed to break bond, and we have also gotten the energy needed to make bond. Now we are going to apply the formula given to you, which is energy needed to break bond minus energy needed to make bond, to calculate our change in the heat. Okay, so if you take in the value, so we see change in heat enthalpy, that is energy taken in, which is the energy needed to break bond, energy taken in minus energy given out. Okay, energy taken in minus energy given out. The energy taken in we calculated was 2,736. As in 2,736 minus the energy given out is 3,462. Can I make it this way? 3,400. Okay, no problem. That is 3,462. 3,462. So our answer is going to be 6 minus 2, that is 4. 13 minus 6, that is 7. And then 6 minus 4, that is 2. Okay, with this workout, if you calculate this in that way, it will not work out. So let's see. We are going to subtract this for digits. So we have minus 726. We have this now like this. We have minus 726 kilojoule per mole. It's a very long way. You will need to pause the video at different stages to get the value. So this is how we calculate change in heat of a given reaction. Anything you don't understand, you just post it and I'm going to respond to them.